Writing Lewis dot structures is probably one of the simplest and most straightforward concepts you can ever run into when you're in a chemistry class, but it actually ends up being one of the most powerful things you can use. And that has a lot to do with the fact that pretty much once you get really deep into chemistry, the one thing that you always keep using over and over and over again are the valence electrons because they are the electrons that undergo bonding. Now, in order for you to really be able to understand bonding, you need two things. You need to be able to write Lewis dot structures to begin with. And the second thing that you really need is to be able to understand the octet rule and how those two things kind of fit together. And so, really, to get the first foundational skill that you need in a chemistry class, you need to really be able to draw Lewis dots. Now, the thing about the Lewis dots is that there's a very minor trick that you need to make sure that you understand, and that trick is actually pretty straightforward. We have the periodic table of elements in front of us, and you can see based off of the structure of the periodic table that there are certain defined areas in the periodic table. There is a difference of how you can name certain groups on the periodic table, and if you don't remember what the groups are, it's really pretty much which column we're talking about. On the periodic table, at any given point in time, there are actually 18 groups. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and then finally it ends with 18. The issue, however, is that there is a gigantic block in the middle, which I'm going to circle right now, that way you can see it, where pretty much when you talk about these guys right here, the transition metals, those are different than the other groups that are the rest of the groups on the periodic table. And the ones that we mainly like to focus on are kind of the ones that are the bigger ones. And in particular, the ones that you really want to make sure that you do focus on are the fact that although this is called Group 1, we can also call it Group 1A. This is Group 2A. We skip the entire transition metals all the way over to 3A, 4A, 5A, 6A, 7A, 8A. Those are what's called the main group elements, and the reason why they're called main group is because they generally tend to be the most important ones. Now, I'm going to get more into that in the octet rule video, explaining why they are the ones that we care about. But for now, that's kind of how you want to think about it. And really, if you pay attention, let's say that you're looking at 13 and 3A. If you know group 13, what you can do is you can pretty much drop the 1 off, and then you realize that you're talking about group 3A. Regardless, the main thing that you really want to kind of just have in the background of your head is pretty much that when you're talking about writing Lewis dots, we do not really think about the transition metals at all. We really just focus on the main group elements. And it just so happens, and I'm going to explain this more when we get into the octet rule, and you're going to see why this happens, but the reason why this is a thing is because it really comes down to electron configuration, and it just so happens that the pattern works out that all you really got to do is look at the major group number and you actually know exactly how many valence electrons you have. So for example, if you needed to draw the Lewis dot for, let's say, sodium. Sodium is a group 1 element, it's an alkali metal, and that means that it's in group 1A, and so that means it's going to have 1 electron attached to it. And then that what I wrote at the bottom is pretty much all that you need. That is your Lewis dot for sodium. If we skip ahead to, let's say, carbon, which is in group 4, and you can go ahead and look at carbon right now, this guy, right? That's group 4A. If we look at that guy and we write the Lewis dot for that guy, we realize that it's in group 4A, and then you just need to make sure that when you write the Lewis dots, you do 1 dot around on each side. Now, the trick to Lewis dots, and this is the one that always really gets people, is that when you get past group 4A and you start going into 5A or 6A or 7A, or when you end at 8A, the one thing that you need to remember that you need to always do is that you always need to cycle around the symbol at least once before you can start to pair up the electrons. And so that looks like this. So for example, if we go next to carbon, we go to nitrogen. For nitrogen, nitrogen is group 5, or 5A rather, 15, 5A, whatever you want to call it, doesn't really matter. That has 5 valence electrons because it's in group 5A. And so that means that you need to cycle around once, so 1, 2, 3, 4. We've now deposited at least 1 valence electron around the symbol. The 5th one, you just begin to cycle back again. It doesn't really matter where you start. But the one thing that you need to remember every single time that you do Lewis dots is that when you do actually write the dots, you need to cycle around once, deposit all four, and then anything that you have left over, that's when you start to pair up. So for example, if we do the next one, let's say we do oxygen. If you do oxygen, that's in group 6A, which means it has 6 valence electrons, just like any other element that's underneath oxygen. And for that one, again, 1, 2, 3, 4, you cycle around, and then you pretty much just do 5, 6. Now this is going to be very important because these Lewis dots are essentially going to tell you how the elements are going to bond, especially when you get to covalent bonding. And so this, even though it seems like it's a little trivial, actually isn't. And you need to make sure that when you write the Lewis dots, you understand that there is a certain pairing order attached to that. And that's pretty much it. Once you have that, you can write the Lewis dots for any main group elements. You cannot, however, write the Lewis dots for any transition elements, at least for right now. So make sure that you realize that. So should anyone ever ask you, like, let's say, write the Lewis dot for iron, you pretty much just tell them, no thank you, I cannot do that. I can totally tell you what nitrogen is. I can totally tell you what phosphorus or chlorine or argon or any other main group element. But just remember that you cannot do it for the transition metals. Other than that, it's a pretty straightforward concept.